All right, today in class we looked at some examples where we had to determine the atomic mass. One of the major things to remember is that there's some vocabulary here. Atomic mass is going to be the average mass for all of the different types of isotopes, or for all of the different isotopes of that element. So this is the average. The mass number is simply the number of protons plus the number of neutrons. So keep in mind that when you see an isotope and its symbol, let's say carbon 14, this carbon, the C is the symbol for the element, and then the 14 is the mass number, not the atomic mass. It's not an average, it's the mass number. Also remember that you might see it like this, where you have the carbon and then the 14 in the top left corner. And in addition, sometimes you'll see the atomic number of the element in the bottom left, which for carbon is 6. For every single atom of carbon, it's 6 because that's the number of protons. And when it's written like this, it's actually very easy to determine the number of neutrons because it's the mass number, 14, minus 6, the number of protons. So you would have 8 neutrons in this particular isotope. Okay, so that's a little bit of review from the previous video. Let's look at how we would determine the atomic mass if we are given several different isotopes, including their masses and their abundance, or how much of all of the particular element is that specific isotope. So let's actually look at an example. This is one we did in class with silver. The symbol is Ag. Silver has 2 naturally occurring isotopes. The first one is silver 107, and I'm going to write its atomic number at the bottom, and silver 109. And again, I'll write the atomic number at the bottom. Again, it helps us remember that that's the number of protons. That does not change. The mass number changes, but that's because the number of protons, or not the number of protons, the number of neutrons have changed, and that is what changes with isotopes. Okay, so in your textbook, and this is number, let's see, we did this problem in class, it's number 77 on page 129 if you want to reference the information again. So in that example, it tells us that the mass, not the atomic mass, but the mass of this isotope is actually 106.905 atomic mass units. So that's close to the 107 for the mass number, but the 107 is a rounded number. This is a much more precise measurement of mass for this particular isotope. And for this isotope, it was 108.905 AMU. Again, very close to the mass number of that particular isotope. So, in addition to knowing the mass, we also need to know its abundance. So, in the information, it tells us that this one is 52.00% of all of the silver that is present. And this isotope is 48.00%. Now, if we're going to determine the atomic mass, again, that's the average mass of all of the isotopes, what we need to do is multiply this mass times the percentage, and this mass times the percentage, and then add up the results. So let's do that. But before we do that, we actually have to change this percentage into a decimal. A key thing to remember about percentages is the same thing as x over 100. So 5% is the same thing as 5 over 100. And if you put that into a calculator, or if you are able to do this in your head, changing that to a decimal should be 0.05. That's 5/100ths. So the easiest way to change a percent into a decimal is to move the decimal place over 2 positions. So now it's 0.5200, and now it's not percent. We can ignore that. Same thing here, move it to the left 2 positions, 0.4800, and now it's no longer percent. All right, so feel free to use your calculator. I'll set mine up here, and I think you'll be able to see what I enter in. So I'm going to put 106.905, that's that first mass, times 0.5200. That gives me 55.5906, and that is AMU. All right, and now we have to do the same thing for this isotope. So 108.905 times 0.4800 gives me 52.2744. At this point, we actually, and this is AMUs, we actually want to add those numbers up. So 55.5906 plus 52.2744. And that gives us an atomic mass, so again, an average, of 107.865 AMU. The fascinating thing about this is that you can then take this number and look at the periodic table and check your answer. Now, it might be a little bit off, and I do believe that on the periodic table in your textbook, it gives you an atomic mass of 107.868 AMU. So 107.868 from the periodic table. Now, those numbers are extremely close, close enough to be counted correct. In addition to just giving me the answer, you will actually need to show your work. So don't try to just write out the answer from the periodic table. Okay. In the next video, I'm going to show you how to do this in reverse. What happens if this is an unknown? What's going to happen if I give you an isotope? It's unknown, but I give you the atomic mass, the known atomic mass, which is the average. So let's look at an example that does that. And the example that I'm going to be looking at is in your textbook, and it is number 114 on page 131. So watch out for the next video.